Then we have Softmax, and Softmax is basically for multi-class classification. You know, multi-class classification. I will not give you the formula; it's just too complex. Yeah, but basically you have a vector of k real numbers, yeah, real values, and you want to convert this to a probability distribution. Yeah, so basically Softmax is a reading of handwritten digits. So the machine learns to read handwritten digits and then classifies them from 0 to 9. Yeah? From 0 to 9. And you get a probability. Probability for 0 is 0.1 and so on. Probability for 9 is 0.6. Right? Now the sum of these probabilities must be 1. So when the function where you find the highest probability, that's the class you will decide on. So in this case we could say, assuming that all the other probabilities are below 0.6, it would classify the input as a 9. Yeah, so k real values, this could be pixels. You need to pixelize the handwritten digits. So that's multi-class classification. And then one that we also will use a lot is ReLU, rectifier linear unit. And let me just first let you see how this works. This is an angle beta. That's the ReLU. Now, let's go back to Sigmoid. What are the good things about the Sigmoid? Good things is that it converts linear to probability. What are some of the negatives? The negatives is e to the minus x is not cheap in terms of computational power. And what is also an issue is that saturation near here. So the saturation, so here this will kill gradients. So that's not very good, because almost the slope is horizontal, so your interesting piece is narrowly defined. So that's one of the big issues of Sigmoid. Now ReLU solves this on the positive side. So here you have a constant gradient. The gradient is constant. And here the gradient is 0. So for ReLU, if we call this one z and this one y, then the formula is y is maximum of 0 and z. So that means if z is positive, your outcome is y, and if z is negative, your outcome is 0. So it's first of all, there is it's a simple activation function. Gradient is 0 when z is negative or 0, and the gradient is constant when z is positive. So it's simple, and no saturation if z is bigger than 0, These are, and it's faster. It's way faster. But that's because it's more simple. Yeah. So this ReLU is very popular. Yeah, for hidden layers. Yeah, at the end of a classifier, we will still look for a sigmoid or a softmax, depending if it's binary or multi-class classification. Okay, this was it for lesson 5 and the perceptron. As I mentioned, no coding exercise. Have a good time. See you later. Bye.